The universe is thought to have begun with the Big Bang, a massive explosion that occurred around 13.8 billion years ago and led to the formation of the universe as we know it today and is still expanding at an accelerating rate. The fireball began expanding and, out of the cooling debris, there eventually congealed the galaxies, great islands of stars of which our Milky Way is one among an estimated 2 trillion. This, in a nutshell, is the Big Bang Theory. The visible universe contains at least 2 trillion galaxies, each containing billions of stars. There are thought to be around 10 to the power of 24 stars in the observable universe, that's 1 septillion or 1 followed by 24 zeros, which is more than all the grains of sand on Earth. The largest known structure in the universe is the Hercules Corona Borealis Great Wall, a galaxy supercluster that measures over 10 billion light-years across. The universe is made up of around 5% ordinary matter, such as atoms and molecules, 27% dark matter, an invisible form of matter that can only be detected through its gravitational effects, and 68% dark energy, an unknown force that is causing the expansion of the universe to accelerate. The universe has the same temperature everywhere. The heat of the Big Bang fireball was bottled up in the universe. It had nowhere to go, so it is still around us today. The weird thing is that its temperature, 2.725 degrees Celsius above absolute zero, minus 270 degrees Celsius, the lowest temperature possible, is essentially the same everywhere. Yet, if we imagine cosmic expansion running backward, like a movie in reverse, we find that parts of the universe that are on opposite sides of the sky today were not in contact when the fireball of radiation broke free of matter. In other words, there has been insufficient time for heat to travel between them and the temperature to equalize since the universe's birth. Astronomers fixed this by maintaining that early on, the universe was much smaller than expected, so heat got around easily. To get from this smaller size to its present size, the universe had to go through an initial burst of superfast expansion, known as inflation. The universe is not only expanding, but it is also accelerating in its expansion, a phenomenon that was discovered in 1998 and is still not fully understood. Black holes, which are regions of space where the gravitational pull is so strong that nothing, not even light, can escape, are thought to be at the centers of most galaxies. Almost every galaxy, including our Milky Way, contains one, but starved of a food supply, most have switched off. Active galaxies often pump out 100 times more light than a normal galaxy. With the discovery in 1963 of quasars, it was clear that light comes not from stars but from a central region smaller than the solar system. The only conceivable energy source is matter heated to incandescence as it swirls down onto a giant black hole up to 50 billion times the mass of the Sun. On September 14, 2015, gravitational waves were detected on Earth for the first time. These ripples in the fabric of spacetime, predicted by Einstein in 1916, came from the merger of 2 black holes in a distant galaxy. Briefly, the power pumped out was 50 times greater than that of all the stars in the universe combined. Each of the black holes was in the 30 solar mass range. Since a black hole is what's left after most of a star has blown into space as a supernova, the precursor stars must have weighed at least 300 solar masses. Such stars are incredibly rare today. But the 2 black holes could have been remnants of the very first generation of stars, thought to be huge, or even primordial black holes, born in the inferno of the Big Bang itself. The cosmic microwave background radiation, which is a faint glow that permeates the universe and is thought to be leftover radiation from the Big Bang, was first detected in 1964. The universe is so vast that even with the fastest spacecraft currently in existence, it would take tens of thousands of years to travel to the nearest star beyond our solar system.